This is how you determine chiral centers and R versus S configurations. Let's say the question says, consider the compound below, determine the chiral centers, label them with an asterisk, and then determine if the chiral center has an R or an S configuration. Step 1, find a carbon center with either a dash or a wedge on it and color it. In this example, I'm using the color orange. Next, hydrogens will not be drawn in. So for example, in this compound, you have a carbon with 3 groups attached to it. Every carbon makes 4 bonds, so we have to draw in a hydrogen. Where do we draw the hydrogen in? There's no wedge, hence we draw the hydrogen on a wedge. If the NH2 group was on a wedge, we would draw the hydrogen on a dash. So now that we've established a carbon center with dashes and wedges, we need to look at each group that it's bonded to and say, are you the same or are you different? To be chiral, the carbon center must have 4 different groups. So let's circle them. Like this, I circled each different area of bonding with a different color. And then I listed the groups 1 to 4. We can see group 1 is an NH2, and NH2 is different than an H. We can see the other group is a CH2 connected to a CH3, which is different than both an NH2 and an H. Then our 4th group is a CH2 connected to a bromine, which is different than every other group that we listed. Hence, none of the groups are the same. To really nail in this concept, consider this compound. If we list each of the groups that carbon is attached to, we can see it's attached to an NH2, an H, the 3rd group is a CH2 connected to a CH3, and the 4th group is another CH2 connected to a CH3. Hence, there's only 3 different groups because 2 of the groups are the exact same, hence this carbon center is not chiral. Now back to the first compound. To determine if it has R or S configuration, we need to evaluate the mass of the groups that the carbon is attached to. So you want to walk as if you're walking upstairs. You're going atom by atom. Who is heavier? If you start at the carbon, you can say, okay, if I go out to one group, I hit a nitrogen. If I go out to a second group, I hit a hydrogen. Who is heavier? The nitrogen is heavier, that group wins. And let's compare that group to the other 2 groups. We can see, oh, I have a nitrogen. If I go out towards the left, I hit a carbon. If I go out towards the right, first atom, I hit another carbon. Nitrogen still wins. So I'm going to put a number 1 by the NH2 group because nitrogen is the heaviest first atom attached to the carbon center. Now for the hydrogen on the wedge, just label hydrogen number 4. Hydrogen will be number 4. So just put a 4, move on. So now for the other 2 groups, you must label atom by atom. So go out to the left one, you hit a carbon. Go out to the right one, you hit a carbon. They're the same. So we must ask, what is that carbon attached to? We can see both of those carbons are attached to 2 H's. Those H's have the same mass, hence we cannot compare them. We move on. What else are those carbons attached to? The carbon on the left is attached to a C. The carbon on the right is attached to a bromine. Who's heavier, a bromine or a carbon? Bromine is heavier, bromine wins. Hence that group is going to be group priority number 2. And then the other group is priority number 3, which I showed here. So now you take the groups and you're going to draw a line from 1 to 2, 2 to 3, and 3 to 4 and ask, is this a clockwise circle or is this a counterclockwise circle? We can see for this question, the circle is going clockwise, hence R, but whenever the hydrogen is on a wedge in your face, you flip it. So instead of R, this is S configuration. That's it, that's all, quick maths. Hopefully this helped. I can do another example for when hydrogen is on a dash. It's much easier. Let me know if you have any questions.